Linda, I'm glad you're able to make it tonight with some great stories.
Yes, I'm telling you, the universe gets more interesting all the time, and tonight I'm going to talk about this puzzling strange star. And it was only about a week ago, on October 22nd, that senior scientist Gerald Harp at the Search for Extraterrestrial Intelligence Institute in Mountain View, California, was talking to Universe Today and said, quote, "We either caught something shortly after an event like two planets crashing together, or we have alien intelligence," close quote. He was talking about that strange star that astronomers call KIC 846-2852.
We got to give it a name.
No, let's just call it KIC for now.
Yeah, really.
This large, mature star, 1,480 light years from Earth, between the Cygnus and Lyra constellations, has the strangest star-light dimming and brightening pattern of the some 150,000 stars in the Milky Way galaxy that Kepler Space Telescope and the Planet Hunters Project have been studying. This is unique. Kepler was launched by NASA on March 7, 2009, specifically to look for Earth-like planets orbiting other stars. On September 14th, Professor Tabitha Boyajian, Yale University astronomer, published in the Royal Astronomical Society Journal a 14-page paper with graphs of what the Kepler telescope has observed the past 4 years. Now, normally, a planet orbiting a distant star will cause that star's light to dim about 1% as seen from Earth. But KIC has had a series of dimming downs, one as much as 22%. The implication is that something gigantic is periodically coming between KIC and Earth. Various suggestions have ranged from instrument defects or artifacts to huge interstellar dust clumps to a swarm of comets. Helping Professor Boyajian sort out what could be happening at the big mysterious star is Professor Jason Thomas Wright. He's associate professor in the Department of Astronomy and Astrophysics at Penn State in Pennsylvania. And there he studies nearby stars, their ages and activity levels, and most of all, their planetary systems. And he has been working on a protocol of characteristics that advanced intelligent structures around stars might produce, such as, if the star blocker is not circular, then the dimming and brightening would not be symmetrical. And that is exactly one of KIC's characteristics. The dramatic dimming and brightening is not symmetric, implying perhaps megastructures orbiting that star. But where did the megastructures come from? That's why media around the world have taken notice. The Washington Post headline, quote, "The strange star that has serious scientists talking about an alien megastructure," close quote. Professor Wright contacted SETI and the Green Bank Observatory for help in observing the puzzling star, and as of Friday, October 16th, the SETI Institute's Allen telescope array was taken off of its normal survey schedule to focus on the star day and night. And here now is Professor Jason Wright from Penn State University in Pennsylvania.
We told SETI that we thought this was a pretty interesting star. People had predicted that Kepler might discover transiting megastructures, and that they should point their telescopes, like the Green Bank radio telescope, at the star and check for signals.
And if I'm understanding correctly, why this is a credible ET hypothesis about some sort of a structure near or around that star is that after 2 years of data, the star's brightness dipped 15%, and after 4 years, it dipped 22%.
Yeah, those were week-long episodes where it got fainter and then it went back to its normal brighter.
So this dimming would last only about 1 week.
Mm-hmm.
Well, now, could you try to explain to me and a general audience what you think might be happening if there is an extraterrestrial megastructure near the star harvesting energy? Why would it have this signature in terms of the dimming light?
The star is getting dimmer because something is passing between us and the star. If it were a planet, it would make the star about 1% dimmer, because planets are small and stars are big, so it would only block about 1% of the star if it were a planet. The fact that it's getting 15 and 22% dimmer means that whatever's blocking the starlight is big. It's like the size of a star, and it's passing between us and the star. Now, we don't know what's passing between us and the star. That's the mystery of this object. That's why it's so interesting, and that's why Dr. Boyajian's paper is getting so much attention. People like a good mystery and want to know what it is. We don't know much about it, but we do know that it takes a long time to pass in front of the star. It takes weeks to pass in front of the star. And those aren't the only two episodes. There are other episodes where the star gets 5% dimmer, 3% dimmer, or 2% dimmer. There are many episodes where the star is getting dimmer. The other thing is that when a star or a planet passes in front, the way that it dims is very characteristic. As it crosses the star is getting dimmer. And then as it leaves, as it goes off the other side and stops blocking the star, it's brighter again. Symmetric pattern there. The way it got dimmer is the same as the way it gets brighter. But in all of the cases in this star, that doesn't happen. The way that it gets dimmer is not the way it gets brighter. And in fact, sometimes it gets dimmer, and then it looks like it's going to get brighter again, then it gets dimmer again, and then it's even dimmer, and it's almost random. And that suggests that whatever is blocking the star's light has very complex structure. So it's something the size of a star, but it's not a circle or a sphere. It's something with a complex shape. And there's a lot of them.
A lot of them because?
Because we see dozens of times the star gets dimmer. Each one of those is a separate object passing between us and the star.
I see. It is taking a long time for the whole dimming sequence to take place over weeks, but it's going up and down in brightness and dimness, and that is why you are describing a mass or a mess of objects.
Right. There's clearly many objects over the course of Kepler's 4 years that have passed in front of this star.
And that it is a fact that of the 100,000 to 150,000 stars that have been viewed by the Kepler telescope, this is the only star, KIC 8462 852. This is the only one that has this particular dimming pattern.
Right, yeah.
So it is unique in a large field of stars.
Yes.
Could you explain what your next research will be in terms of trying to get access to massive radio dishes to look at the star?
We put in a proposal with the National Radio Astronomical Observatory to ask to use the 100-meter Green Bank telescope in West Virginia to observe this star. And we've teamed up with folks at the Berkeley SETI research who use and equip this telescope with devices that are designed to detect what they think signals from alien civilizations might look like. We've asked if we can use the telescope to look at this star and see if we can detect radio waves.
What has the answer been?
We won't hear back for weeks.
Oh. But if it is positive, when would you begin to be able to look at this star with the Green Bank telescope?
They would have to schedule a time for us to do that. It would be sometime early next year.
From your general work and interest in looking for these architectural megastructures in stars, can you explain that you've helped develop a protocol for seeking signs of unearthly civilizations? Could you explain that protocol?
Basically, I asked the question, if there were a megastructure around a star, orbiting the star, how would that appear different to Kepler than a planet? There are many ways that it would appear different from a planet, and I tried to enumerate all the different ways. If it didn't have a circular aspect, then when it passed in front of the star, the dimming and the brightening would not be symmetric. It would not dim the same way that it brightened because the object might have a symmetric shape. So that was one way that you might tell. Another is that if it's a large structure blocking the star, then it'll block all wavelengths of light, all colors of light the same. But if you have a planet, the planet can have an atmosphere, and the atmosphere will selectively block some colors and not others. You could tell that the planet has an atmosphere, a megastructure would not. Planets are massive, and so they pull on their stars. You measure the velocity of the star. You can tell how massive the thing orbiting it is. And so a planet would tug a lot on the star, and you'd be able to measure the planet's mass. A megastructure presumably would not weigh as much as a planet, and so the star would not be seen to move at all.
How does this star, when you match it up against your 10 protocol items, how many of your 10 apply to KIC 84?
Almost every single thing that I listed, all 10 signs, has been observed, but for totally natural reasons. There's no reason to think aliens are involved.
But aliens are a credible hypothesis when it comes to KIC 84 because this is the only star.
Interesting. I don't know about credible. I mean, it's very unlikely. It's very, very unlikely that this is aliens. There's almost certainly a natural explanation. I don't think the comet thing works very well, but it could be that. But it's probably something we haven't thought of. I mean, it's worth pointing the radio telescopes at it to check.
And when you do get the Green Bank telescope aimed at it, what will you then be looking for to decide if this could be alien megastructure?
So this is a question for the SETI folks, because they're the ones that do this work. But my understanding is that they're looking for radio emission at a single frequency that's modulated in a certain way. So sort of like if you turn on your AM radio station and you just heard this modulated signal. It's like hearing a pure tone on your AM radio, like a dial tone.
Mm-hmm.
Just one tone. That's basically what they're listening for. And they've built specialized equipment that can listen for that. And that's what they'll check to see if they can hear from that star.
What will you and Professor Boyajian and your group that are going to use the Green Bank telescope, what will you look for in the next round of research of the dimming itself to try to see whether or not you think it goes into the evidence category of being some kind of megastructure?
We're going to take spectra past the starlight through a spectrograph that breaks it up into all of the different colors of the rainbow. And we want to take a spectrum of the star when it's bright and then again when it's dim and compare the spectra. And the difference between those two spectra will tell us how much light is being blocked at every color by whatever's blocking the light. And this is a technique that astronomers use to determine the composition of material. If you shine a light through it, it blocks some colors, it doesn't block other colors. And the pattern of colors that gets blocked tells you what the material is made of. And so then we will know what the material blocking the star is, and that will help us figure out if it's comets or a planet or whatever's making it dimmer.
Now, could you speculate on what you might see in data if it were, in fact, an alien megastructure?
Well, we obviously don't know what an alien megastructure would do to light, but if it's just a big opaque object like solar panels or something, then we won't see any difference in the spectrum. Is that there's something blocking the light. But if it's a comet, the gas in the comet will block some colors and not other colors, and then we will see a difference in the spectrum.
And what else might separate the wheat from the chaff? Something that you'd look for, nature versus architecture.
Another natural cause would be dust. Dust tends to let red light through but block blue light, so that would cause a characteristic pattern where when it gets dimmer, it gets much dimmer at blue light wavelengths, not as dim at red wavelengths. And that would be a giveaway that we're not looking at a gas cloud, but a dust cloud. And the amount of that reddening that we see will tell us how much dust is there.
But what if it isn't dust and you don't see that evidence? Then what?
Well, that's a great clue, because if it's not dust, then that's really going to narrow it down to large, massive objects. I don't know. We're going to have to go to the theorists and say, how do you block the starlight without seeing the signatures of dust? That'll be a real mystery. That'll be hard to figure out. But the eureka moment with an alien, I don't know how to do that except with the radio waves.
I see. But I'm thinking that if SETI comes into this after you have done the Green Bank telescope work and they found that pure tone, then this could finally be that which breaks open this question that has been there for centuries. Are we alone in the universe? We could discover advanced intelligence. It would be far away, but it could be a new reality, like a revolutionary breakthrough from this star. that there are advanced intelligences harvesting energy from stars, just as science fiction has written about.
Yeah, that would be pretty cool. Yeah, I mean, that's the goal. That's why you work on SETI. That would be amazing if it happened, and so we should spend at least some resources trying to make it happen.
Great job on that, Linda. He's got an open eye to it, but he still thinks it's highly unlikely it's ETs.
Well, it is so fascinating, and the American Association of Variable Star Observers published an alert notice this week requesting amateurs and professional astronomers around the world to immediately begin observing KIC 84. And for people listening who would like to do that, go to the AAVSO website, that's American Association of Variable Star Observers, and you just type in the KIC number in the Pick a Star box to create a chart of your own, and you can help contribute to everything that is now being focused on this strange star. And it's so interesting, George, that the idea of a megastructure, an intelligent megastructure that could completely encompass a star to capture most or all of its power output for a very, very advanced civilization, first was a thought experiment by Freeman Dyson back in 1960. He did a paper for the journal Science, and he called it Search for Artificial Stellar Sources of Infrared Radiation. And he started it with a thought experiment because he theorized that all technological civilizations constantly increase their demand for energy, just like we are on this planet. And he reasoned that if human civilization expanded energy demands long enough, there would come a time when it demanded the total energy output of our sun. And he proposed a system of orbiting structures, which he thought of as a shell, that's why it's called a Dyson shell, designed, or sphere, designed to intercept and collect all the energy produced by the sun. And Dyson's proposal did not detail how you would build such a structure, but since 1960 and that suggestion, this idea has been there, and suddenly in 2015 September, we have something for the very first time ever looked at from this planet that is raising the question that maybe the Dyson Sphere, or what Kardashev in the Soviet Union said could be type 1, 2, and 3 civilizations, and type 2 would be a civilization capable of harnessing the energy.
That's right. We're not quite there yet, but we're getting there. But it's fascinating just to think about, and it's 1,480 years ago. That's what we're seeing right now. Linda, a cold blob in the ocean? What the heck is this all about?
Well, you know, back on December 14th, 2002, 13 years ago, I did my first Earth Files report about the North Atlantic Oscillation that combines with what's called the North Atlantic Drift, sort of like a huge conveyor belt that brings warm Gulf of Mexico waters northward, and that warms the temperatures along the eastern North America coast and Western Europe. And back then, the journal Science had published findings that 6 of the world's biggest freshwater rivers in Eurasia were dumping a lot more water into the Arctic Ocean due to melting permafrost and glaciers as the Earth is warming up. And the concern then was whether all that fresh water would dilute the salty North Atlantic enough to slow down, even stop, the big conveyor belt that is also called the Atlantic Ocean's people have different pronunciations. I say Meridiano, overturning circulation,
right,
or AMOC. It's easier to say.
I'd go with your pronunciation.
Yeah. AMOC is driven by differences in ocean temperature and the salt content in the North Atlantic. Well, today, in October 2015, even more fresh water is melting off of Greenland into the North Atlantic, adding fuel to the scientific controversy about whether the big warming conveyor belt will be so diluted that there won't be enough salt that's necessary to sink cold water, and that drives the circulation. Adding to the confusion now is that in spite of great heat in both the air and water of the Gulf, and 2014 going down in the record books as the hottest worldwide year yet, a huge blob, and it's increasing in size, of abnormally cold water, record-breaking in some of the temperatures, has been observed in the North Atlantic Ocean beginning only 2 years ago. The giant mass of record-breaking cold water is between southern Greenland and Europe, and it is assumed to be Greenland ice melt runoff, but no one knows why the massive cold blob keeps growing unaffected by the warm Gulf waters moving northward. Earlier, in 2015, there were a couple of scientists who published in Nature Climate Change their concern that this circulation is growing weaker. And Michael Mann of Penn State and Stefan Rahmstorf of Potsdam Institute for Climate, they said that their data shows a persistence and that the conveyor belt grows weaker. Here's the problem. One of the many serious consequences, if this is true and persists, is that there will be rising sea levels for the U.S. East Coast and possibly cooler temperatures overall in the North Atlantic and Europe because of what happens when there are these kinds of temperature variations. Reinforcing this concern has been James Hansen, who was head of NASA Goddard Institute for Space Studies from 1981 to 2013. He now directs the program on climate science awareness and solutions at Columbia University's Earth Institute. He and 16 other scientists got together for a July 2015 paper, and they wrote, quote, "If the ocean continues to accumulate heat and increase melting of marine terminating ice shelves of Antarctica and Greenland, a point will be reached at which it is impossible to avoid large-scale ice sheet disintegration with sea level rise of at least several meters," close quote, and he was talking by the end of this century in another approximate 85 years. Now, I took all of this. Thomas Delworth, PhD, research scientist in NOAA's Geophysical Fluid Dynamics Lab and professor of Atmospheric and Oceanic Sciences program at Princeton University in New Jersey. Here now is Professor Delworth.
It is absolutely true that the amount of melting is increasing over Greenland, and that's very large by some measures. But how much that is leading to this cooling in the Atlantic is just not clear. This cooling has only been here for a year or two.
Well, what do the models from your Geophysical Fluid Dynamics laboratory indicate might be the source of all of this cold water in the northern Atlantic?
I think without additional measurements right now, it's very difficult to say what's causing that. There are several factors which could be going on. One, we've measured over the last 2 years, there has been a weakening in how much heat the ocean is transporting from the tropics into the higher latitudes. So that reduction in the amount of heat being carried by the ocean could be a significant player in this cooling. We've also seen the last 2 years stronger than usual winds over the North Atlantic, over that region. Those could actually be cooling the ocean directly by the atmosphere.
Well, let's go to the big implication if the Atlantic conveyor belt that is called the Atlantic Meridional Overturning Circulation, or AMOC, the big rotation of warm Gulf waters off of Florida and the Gulf that are churned up to the North Atlantic under this big conveyor belt system that is dependent upon the density of salt water in the north to sink. But if there is a tremendous amount of fresh water coming off of Greenland, for example, into the North Atlantic, that could dilute the salt density enough that it would slow and maybe even stop this conveyor belt in the Atlantic.
Many model simulations have been carried out to try and look at exactly that question. And to the best of our understanding right now, in response to global warming, we absolutely expect these ice sheets to melt, and they will put fresh water into the Atlantic. But our models suggest that that reduction in this overturning circulation will be fairly gradual and slow. And so it looks to us as though the result will be not some sort of catastrophic collapse, but a slow, gradual weakening. And that slow, gradual weakening is happening at the same time as the entire planet is warming due to the greenhouse gases. The most likely outcome of this weakening of the circulation is to moderate the warming, say, over Europe and over parts of the North Atlantic. So it does not appear to be leading to a catastrophic cooling.
There have been some headlines that Western Europe could end up facing much colder winters. Do you think that's possible?
There's very little evidence to support that. The idea that this weakening or collapsing AMOC will cause severe cold over Western Europe is just not well supported by the science at all.
There is another issue about the wind patterns in a globally warming planet. And some of the computer models of people that I've interviewed are indicating that even the rainforest in Brazil by the end of the century might pretty much be gone because the wind patterns that carry moisture, they are changing. And you can have drying atmospheric motion and you can have wet atmospheric motion, so that the dynamic would be even greater rains and flooding in some areas and increased droughts in others. Have you been studying models that would indicate that the Brazilian rainforest could be gone at the end of this century?
Our models have not shown that. But what I will say is that when we increase greenhouse gases, we first of all warm the planet. That's like a very direct effect. Then precipitation and rainfall changes are harder to predict. They're not as clear. But there are some really robust signals that we think are quite clear. For example, the Mediterranean region, Italy, Greece, Turkey. Almost all models show that will suffer reduction in rainfall going forward, so there'll be more and more droughts there. Some regional areas, such as the Amazonian rainforest, some models show a lot of drying, some models don't. When that happens, we just have less certainty. Mm-hmm. And so that requires a lot more study. And some areas are inherently hard to predict. For example, every indication is that as the planet warms, more water vapor, more moisture will move into the very high latitudes of the Arctic regions, northern Canada, Russia. Every indication is those areas will experience very significant increases in precipitation, rainfall in the summer, snowfall in the winter. We're very confident in that.
If the atmospheric wind patterns are contributing more moisture that is gathered up from the oceans and depositing it over Antarctica, then a buildup of snow and ice there could still be consistent with a globally warming planet.
Certainly that's possible. The ocean surrounds Antarctica. It's actually one of the last places to warm up because it's very cold water, it's very deep water, and it takes that heat from the near surface layers and brings that down into the deeper oceans. Now, of course, it's very much in the news that sea ice has not been receding around Antarctica. It's actually been a slight increase, and that's a subject of very intense research right now. And I think it's consistent with this idea, one, that that's the slowest region on the planet to warm up because of the influence of the very deep, cold ocean surrounding Antarctica that absorbs a lot of this heat. So it actually is the slowest, one of the last areas on the planet to warm up. And so the idea of increasing sea ice on a time scale of a decade or two or three is not at all inconsistent with global warming. We expect that area, to be one of the last on the planet, to really fully warm up and experience the effects of increasing greenhouse gases. We've also had interesting research that shows that changes of ozone, the ozone hole of Antarctica, have a big impact on the position and strength of the winds in the southern hemisphere. And this also has an impact on where sea ice is. So it's actually a complicated area in the Antarctica ocean.
The Antarctic can have increase in ice and snow and still be part of this complicated pattern of global warming.
That's right. And that's why it is a really fascinating global climate system, because you can have very different effects. One of the biggest documented changes we've had in the whole climate system has been this movement of the southern hemisphere westerly winds. They move just a few degrees of latitude poleward, but in terms of the climate system, that's a huge change.
Meaning to the South Pole.
That's right, towards the South Pole. And so by doing that, they've had a big impact on the climate system, from rainfall, parts of South America, Australia, ocean circulation changes. And that change in the winds is really due to human activity because it's a combination of increasing greenhouse gases and the ozone hole over Antarctica. Both of those tend to make these westerly winds stronger and move for the South Pole. So it's a very dramatic and clear effect in the entire planet of human activity.
Do you have computer models that go forward, say, 10 years, 20 years, 30, 40, 50, where you at least have what the computers are projecting the planet will look like with the conditions that you know now programmed in?
Well, certainly we use models to make projections of how the climate will evolve over the next 100 years. Yes, we do.
What do you see change the most dramatically between now and the end of the century?
Well, the largest changes, we see this tremendous reduction in rainfall in the Mediterranean. That's going to be a big player. We see increases in things like heat waves, heat stress. If you live in a state like Pennsylvania, as I do, or Wisconsin, or someplace like that, in 100 years' time, it's as if your state's been transported southwards, closer to the Gulf of Mexico. So your whole climate system changes. I think that's a very good way to think about things, that every few decades your state sort of moves further and further south in terms of its climate. And that has big impacts.
Wow, in everything from insects to birds to the trees to everything is going to have to keep changing.
That's right. And the longer the planet continues to warm, the larger these changes are, and it may have a whole set of implications or impacts that we haven't foreseen now. Perhaps the most important thing is, what are the surprises that we're not even thinking about yet?
Is it true that in a warming planet, that the storms like Sandy, like hurricanes, tornadoes, the big dynamics are going to increase intensity?
If we talk about hurricanes and tropical cyclones, our best evidence to date suggests that into the future, by the latter part of the 21st century, that the strongest storms will get even stronger, but we may have fewer total storms.
Why?
That's a good question. The really strongest storms feed off more of the energy in the warmed planet. Why there are fewer storms, it's really not understood.
In the United States, the biggest populations are in the coast, and the East Coast has already started flooding even with the tug of the moon. Florida, they just have video of that. So aren't we facing, even in the next 10 to 20 years, increased numbers of flood events along the East Coast, for example, with a political challenge? What do you do with all of these structures and people that probably, if logic prevailed, should be moved inward away from the coast?
It's very clear that sea level is rising and will continue to rise. It means the very highest tides, the highest surges are that much higher, and so that's a huge problem. It's also a fact that as the Atlantic circulation weakens, which we discussed, that actually leads to further increases in sea level along the northeastern coast of the United States. So it gets a double whammy, one from increase in sea level due to global warming and land ice melt, and two, a weakening of this circulation also increases sea levels. The northeastern coast of the United States is particularly vulnerable. And Greenland, if it melts completely, would raise sea levels around the globe by about 20 feet.
Wow.
But that's the small kid. Antarctica is the big kid. And the sea level rise from Antarctica is potentially much, much larger. The problem is we don't have at all a good understanding of how rapidly these ice sheets will melt. It's a huge unknown.
Well, there's another data point from NASA, October 6th. This was looking at what has happened to Antarctica ice this year. And this year's maximum ice fell much lower to roughly the middle of what has been measured over the last 3.5 to 4 decades from satellite observations. And scientists speculate that it is possible the spreading warmth from the El Nino in the Pacific Ocean has dampened the Antarctic ice buildup. Scientists are stressing that when there is great ice ringing Antarctica, as in the recent decade or so, it is a kind of paradoxical confirmation that climate change is warming Earth, because computer models show that southern hemisphere winds are stronger than they used to be because of a warming atmosphere. And one consequence of that warming in the air and the change in the winds is that sea ice that melts and breaks off of Antarctica clusters around the continent instead of floating northward and melting. And that is another one of the possible answers to what has been a mystery about Antarctica.
It's an amazing planet, Linda, and it's a violent planet, isn't it?
Dynamic, ever-changing, and it has always been that way, will continue to be. And the challenge now is, as the population, which is huge going forward into the 21st century, with areas that are definitely going to go underwater, drought in the Mediterranean, all kinds of issues, what can we do with our own advancing technologies? I'm thinking about if there were a civilization that could build an entire structure around a sun for energy, what can humans do on the Earth in the 21st century to help accommodate the whole human population while the Earth, the sun, and the solar system are sort of doing their thing, with us contributing to this blanket around the Earth with greenhouse gases? It is a century that seems to have so much potential, George, that if the right decisions were made, it could be so positive, and we all feel the tension of things so negative and self-destructive. And it's like we are right now, in this very month and year, we are standing sort of on the razor's edge. Which way is this planet going to go with humans?